In this unit, we discuss calculating confidence intervals and performing hypothesis testing for the difference in two populations. That is, we want to compare and draw conclusions about the population parameters from two different populations based on samples of observations chosen from each population. Statistical inference broadly works the same way for two populations as it did for one population. With a single population, confidence intervals were generally calculated as a point estimate plus and minus a margin of error. And we had some amount of confidence that the true population parameter from that one population would lie in that interval. With two populations, we're not bounding a single parameter, but the difference in parameters from each population. For example, the mean difference in daily throughput from one factory to another lies between bounds A and B with 95% confidence. And the idea of a point estimate plus and minus the margin of error is the same. We have a point estimate for the difference in population parameters, and we add to it and subtract from it a function of variability, sample size, and confidence. With hypothesis testing, the same general approach holds. Rather than testing the similarity of a population parameter to some hypothesized value, we test the similarity of differences in two populations to some hypothesized value. The same three possible sets of hypotheses still exist. We could have strict equality in H0 and strict inequality in H1. We could have greater than or equal to in H0 with strictly less than in H1. Or we could have less than or equal to in H0 with strictly greater than in H1. And statistical inference can be performed for the differences in all three of the population parameters that we've previously discussed: population means, population proportions, and population variances. With population means, we have different approaches for when the population standard deviations are known and when they're unknown. When they're known, we use a standard normal distribution in the calculation of confidence intervals and in performing hypothesis tests. When sigma 1 and sigma 2 are not known, where we would realistically estimate them with S1 and S2, we use a student's t-distribution instead of the standard normal. And within the situation where sigma 1 and sigma 2 are unknown, we have two different approaches when we can assume that the dispersions of the two populations are roughly equal or when they're roughly unequal. We found that we can perform a comparison of variances with an f-test to determine which assumption to make about sigma 1 and sigma 2, ultimately telling us which standard deviation and degrees of freedom to use in the comparison of means. Or we may want to compare variances on their own, just to compare the variability in two different processes or systems. Finally, we may want to compare the proportions of successes found in two different populations. And in this situation, we use a z-distribution, assuming that sample sizes are sufficiently large. And this ends the unit on statistical inference for two populations. And it concludes our discussion of parametric tests for inferences about population parameters. The tools of statistical inference are useful, and they remind us to not trust point estimates as estimators for population parameters.